Now let's do it the Lagrange way. This is going to get interesting. Again, what's step one for Lagrangian, guys?
Right.
You can write it. What do you write it as? Just like you did the force equations, you wrote the force equation. You're going to write the Lagrangian now. Good? Now, the next step. What's the next step? Okay, which coordinates would make sense? X, Y, and Z. Again, X, Y, and Z are good ones to choose. Okay, number one was write this, right? Number two is the coordinates. Good. Number three is find T in terms of the chosen coordinates. What would it look like? Number four, find the correct potential. What do you think the correct potential is? mg, yes. And should it be minus or plus? Think about where your origin is. As h goes up, does the potential go up or down? So as h increases, b should increase. So what's the relationship between b and z? Directly positive. Now what's step number 5?
You're gonna put T in the equation.
Okay, so will this look like this? Okay. Now what's step number 6?
Use the Euler-Lagrange equation.
Which one?
That's the question. This is
The first one, right? Because we are talking about a conservative system. So we choose the number 1, and I'm going to write it here in terms of generalized coordinates first. Dot. Don't forget those dots, guys. Okay, so now how many of these should I have? Good. 1 along the x, 1 along the y, and 1 along the z. Woohoo! Okay, so now I'm going to rewrite this d over dt of partial L over partial x dot minus partial L over partial x equals 0. Do you see why I'm being so specific about this? I'm rewriting them over and over again just to make sure I don't mess up. And I have messed up a lot while doing these kinds of problems, especially when you do them for the first time. But I will tell you, if you follow this recipe, the likelihood of messing up goes exponentially down. I didn't say it goes to 0 because we can always mess up, but it goes down. Dot minus 0 equals 0, and d over dt of mz dot minus mg equals 0. Do you see where the zeros and the mg's are coming from? Okay, so that means this will become m double dot equals 0, my double dot equals 0, and mz double dot equals mg. Oh, wait, it should be plus here. And that should be a minus. Isn't it exactly the same as those equations that we got? I'm going to call this Newton 1. Are they not identical to those 3? Woohoo! So these ones I'm going to call Lagrangian ones, right?